Tonight's explorations are assisted by Dark Mulled Spiced Dark Ale from Kilter Brewing in Winnipeg. They describe it as warming and aromatic, infused with cinnamon, nutmeg, clove, ginger, and citrus peel. Those all sound a lot like Christmas baking, don't they? Yeah, that tastes very much like it would go with Christmas baking. It's interesting, not my usual style. Anyway, today I am playing with this battery spot welder that I got in a recent mailbag video. On the front of the unit we have a USB-C for charging, a USB-A for output. Yes, this thing can be a battery bank. It claims 2.1 amps. And then we have these two ports here, which is where you plug the probes into, and they've got, I'm not quite sure, these look like the pins out of like one of the higher current XT series connectors. I don't have one, XT90 or XT100, something like that. I'm not sure what those bigger ones are. I haven't played with them. Anyway, those just plug in there, and it is very, very firm feeling when you put them in. Then we have two push buttons over here, an on-off select and an up-down go around and circle one, although what that really does is just, it's only a single push button. It cycles through the menus. And just above it, there's a little hole there, which you stick a piece of wire through to hit the reset button in case the processor loses its brains. And then on the front, we have a little screen. Push and hold the button. There we go. Here's what the screen looks like. Currently, it is showing fully charged, 4.16 volts. A whole 9 degrees on the internal thermocouple or temperature sensor or whatever. The current of the last zap that you used it for, right now it's 0 because I just turned it on. This is kind of a bar graph when you're setting the power output on it. I'll show you that in a second. Then there is these items down here. Preheat for 2 milliseconds. That's adjustable, I think. Gear, which is the strength, the speed, the power, in milliseconds. It's certain. So currently it is set to do a 15 millisecond burst of full current. And then the number of hits, you can have it do multiple pulses of high current, and then the gap between those pulses. So right now it's just set to 1, and the gap doesn't matter, but it's set to 15 milliseconds. So if you tap through the white button on top, it takes you to, you know, see it's highlighting things to different menu positions. And in this gear menu, we can set a bunch of parameters. I'm not going to worry too much about them. I'll leave the speaker on, leave it in English, screen brightness at full tilt so you guys can see it. It does have an auto shut off. It does alarm on overtemp at 60 degrees. It does have a log, which I haven't looked at yet. Oh, it's been up for 16 seconds. It's done 50 seconds worth of welding, and it's got an ID. Okay, whatever. And go back to the menu, right? So if we scroll through these switch states, that just goes to a different menu. Shows that the USB-A and USB-C are both off. If I plug a load into the USB-A here, that turns on, and it doesn't show it as being on. That is interesting and weird. Anyway, it shows the battery state, 100% charged, all the rest of that. So we just go back to the normal menu, go into gear, and if I tap on the black button, you see that bar graph going up for the amount of time or the length of the pulse that it sends. It drops back down, so 30 milliseconds is the top. But I'm going to set it back to, I think, 15, which is what it was out of the box. The gap between, and then the number of hits. You can do up to 5 of them by the looks of it. But I am just going to leave it there for initial messing around. Now, in the box, it also came with some nickel strip just to play with. And I really don't know what this is, other than it being insulation paper. Although it, oh no, it is sticky backed. Okay. So there's some kind of maybe sticky backed installation paper for when you're building battery packs. I don't know. Regardless, I have a salvaged lithium cell. This one is dead. It wouldn't take a charge. That's why the pack that I took it out of was available for salvage, I guess. I am just going to try and weld on, just using the default settings, weld on a chunk of this nickel strip. Probably should cut that off, but I'm just going to leave it long for now. What's the worst that could happen? Like I said, this is a dead battery. So I'm just going to hold one probe against there, and then when I touch the other one, there should be a bit of a delay. Then it should pulse and weld. You see that little puff of smoke? And there, that piece of nickel strip is welded on there. And it's fairly secure. Yeah, you can pull it off if you try to, but it took a fair bit of effort. And there is the remnant of the weld. That is the side that was facing the battery. See that discoloration there? That is from the heat. So what happens when this is being welded? Basically, it is dumping a massive amount of current. So that shot used 794 amps, or pulled 794 amp out of the welder, and jammed it through the distance between those two probes there. Massive 8-gauge cable, so not much drop there. So when you put, almost 800 amps through a tiny little bit of metal there, that's going to create a tremendous amount of heat just in that area between the probes. And that heat essentially melts the nickel strip a little bit, and or the nickel on the end of the battery there, and fuses them together with no welding wire, no filler wire, no nothing else. Just the heat of the short circuit in there. So I'm going to try and bump this up a little bit. Let's just see what did I say the maximum was? 30? Yes, it is. So let's fire that up to 30. And I'm just going to blast it through just a couple of pieces of nickel strip without the battery, because the top of that battery is getting pretty beat up. So let's just see what happens here. Oh, wow. Not sure if you could see that. I could see glowing red on this thing, but it's slightly warm to the touch. So that's the side where the contacts were. And that's the back side. There's discoloration back there too. So that did a solid job of fusing those together. Even though I can rip them apart, it takes a fair bit of effort to do so. And that was 860 amps. Let's just go to ludicrous speed here and use maximum power and 5 hits and just see how solidly I can weld these two pieces of nickel strip together. I assume this is going to melt a hole in there, but we will find out. 1, 2, 3, 4, 5. Wow. Hope you could see the smoke coming off that. That actually did get quite warm. It discolored my silicone heat mat here too. But can I rip this apart with my bare hands? No, that's not even coming apart. Okay, so clearly it did the job. I am pleased with that. I just got to make sure I don't throw my tools across the probes, because that could be bad. So if I didn't mention it, the reason that you want one of these things is if you are assembling packs of lithium batteries, you don't really want to be soldering them just by blobbing on there with your soldering iron like I have irresponsibly done in this little homemade pack, because it takes a lot longer to heat up. It soaks heat into the battery, and as we've all been told time and time again, lithium-ion batteries really don't like getting too hot. They tend to get sparky and burny and explodey if you do that, so you really don't want to do that, and it was kind of irresponsible of me to do that with this one, but that's the only thing I had available to me at the time. Plus, with that, it didn't even make a very solid connection. But I think, now that I do have some solder on there from before, I think if I take this thing and turn it back down to a more normal level here, let's turn it back down to, let's go to 20. 15 was a little cool. Let's go to 20. Sure. And I'm going to see if, when I hit this thing, if I can create enough heat in that short burst to reflow that solder and melt it on. This is not ideal. There shouldn't already be solder there, but that's where we're at, so we'll go with it. Ooh, I felt that actually physically drop into the puddle of solder as it melted. Just going to do another pair this way. There we go. Now that is firmly down in there. And I think I'm just going to quickly go around to all of the connections on this dubious little pack. I am going to try what I said I didn't want to do before. I'm just going to go on either side of this solder. Well, no, one on top of the wire and one on the battery. I think that will melt the solder blob. Yikes. That was horrible. That was probably ill-advised. Oh yeah, that looks like it was a bad idea. Oh no, the manual such as it is covers this. Check the tip of the welding pen for black oxide sandpaper cleaning. Okay, to avoid sparks. Alright, I can do that. This is, what is this? This is 600 grit. It's just what I happen to have handy. It may be a little bit too fine for this job, but oh no, that shined right up. Okay. Good, I didn't destroy them. Although, if I did burn it off, this is just a chunk of copper that's crimped onto the end of the wire. There's nothing special in that probe tip, so I suppose I could file it down to a point again if I had to. But now, let's get to the interesting thing. Opening it up and seeing what's going on inside. Wow, those really are stiff. So the case has 4 screws on this end and 4 screws on that end, and I'm going to assume that the board just slides out from the inside. As long as the batteries aren't glued in or something, we will find out. Oh, that's just a piece of circuit board with some screen printing on it. Okay. Huh, neat. Interesting way to make a cover. So can I just slide that out? No, I need to push it out from the back side. Okay. More screws. I assume, anyway, maybe there's some surprises in here, but I don't imagine there is. It's probably just all wedged in there, or maybe some adhesive on the batteries, like I said. Oh, there are 2 good-sized lithium pouch cells in there, and a circuit board that's held into the little rails of this case. I'll just slide that stuff out of the way and push gently on the board. Oh yeah, it's coming. Okay. There we go. So these 2 pouch cells are 3.7 volt lithium, as we expected, 7.4 watt hours. All right. There's a little piece of foam tape wedging them in. Then we've got a little screen here and the connections stuff. And oh wow. Those batteries are bolted right on there. Did not expect that. That's kind of neat. I think I am going to carefully lift this LCD off here as well. I can see some stuff under it that I want to get at. Oh, all the screws are the same. That's nicely done. Oh! Careful, careful. There are some spicy batteries attached to here that I cannot disconnect from the circuit. That just lifts off its little 8-pin header plug. Okay, I'll set that aside so it doesn't get damaged. Wow, yeah, there is the battery tabs connected on there. Those are just nice wide pieces of nickel coming right off the battery tabs. Yikes. And we have a 2200 microfarad 10 volt capacitor on here for some reason. I don't think that's got anything to do with the discharge. We got a couple of devices there, and what are those? Oh, that is just a chunk of copper that's soldered onto the board to beef up the track. Wow. So the positive looks like it is connected directly to the one output terminal, and the negative looks like, I'm going to guess those are MOSFETs that switch the current through just from there to that little bus bar and out to there. Oh, so there's 4 MOSFETs, 2 on each side of the board, presumably all in parallel on that negative side, switching the thing. Okay. GFV 148. I'll show you that was the date code that I was reading before. Here is the actual marking that I found elsewhere on it, 5N04N010. It is a 200 amp MOSFET. Wow. It looks like it's designed for automotive applications. And so 40 volts, which is fine because this is only like 4 volts, but 4 200 amp MOSFETs in parallel to dump that current for up to 30 microseconds. Milliseconds, sorry, 40 milliseconds. So yeah, okay. Pulse drain current 800 amps. Okay. Yeah, continuous 200, and this is pulse, so one of them theoretically could handle the pulse that we're giving it. There's 4 of them in parallel. Okay, that's more comfortable. So this capacitor over here looks like it's part of a power supply, either a boost or a buck. There's a couple of inductors there and another one over here. This one is probably for that power bank output circuit coming off that chip, I would guess. And these two, at least one of them is probably powering the brains over here, and the other one is very likely to do with the battery charging. That'd be my guess. There's a buzzer down there too. Let's see what this brain box is. Being careful not to get my magnifying glass anywhere near that. That's just scary. HK32C030C81 ARM. An ARM microcontroller. Okay. The only data sheets I could find were in Chinese, so I had my friend Google translate it. This is an ARM Cortex M0, 64 megahertz, built-in 64K flash, and 10K of SRAM, 3K bootloader space, SPI I2C, all your usual microcontroller stuff. And according to LCSC, they are 73 cents each for this microcontroller or microprocessor. No, microcontroller. Okay, wow. So I guess about all there is to do is put it back together, try not to hurt myself, and see if it still works. The more I look at this thing, the more I am impressed with what it is, especially for the fairly cheap price that I got it for. This is the tricky bit, I think, getting it to go back in there. I've got to get the board in its slot, because I don't want these bolts shorting against the case. Get those spicy little pillows in there. Slide that down. And there's nothing to stop it from going right through, so I'll just stop it there and reverse the process of taking it apart, which you've already seen. There it is back together. Let's see if it still works, because that would be nice. Power, good. Still shows 4 volts, 98%, 14 degrees inside. Cool. Just for the fun of it, let's see if I can parallel up a couple of AA cells. They should have the same type of metal on them, I hope. We shall see. I'll just hold that in place there, and yep, that definitely welded. That definitely welded as well. Let's get this Kapton out of here, and yep, no. Didn't quite. Oh, it blew right through it. Okay. One of the probes was only on the nickel. It wasn't on the battery top. Okay. Now let's try this again here with both of them actually touching both the metal and the battery contact at the same time. There we go. Now that held together. Okay. So you can use it to make packs of non-rechargeable batteries if you so choose. Although I don't know exactly why you would choose that, but it's an option. But of course, it is designed specifically, and it mentions even that it is for more of this type of cell. And these are the ones that you normally find welded together in packs. And as I demonstrated there, you can definitely use it to make up a pack. Use it to weld 2 pieces of this nickel strip together if you choose to. And with the wide range of settings on here, you can use different thicknesses of the nickel strip and things like that. They sent a nice long chunk along with it, and I've got some already in stock that I've used for other things in the past. So yeah, I think that's a reasonable addition to my cheap tools. I wouldn't try and run a shop with this. It's not designed to be a professional unit, but just for a hobbyist unit, the amount of stuff that you're going to do as a hobbyist, I think that is a pretty good low budget option for battery welding. If you got any experience with this, if I missed anything, comments or questions, any of that stuff, you know the drill. Leave it down below in the comment section. Thanks for watching. I will be back next week with more shenanigans and electronics and beer. Yeah, thanks for watching. I will talk to you later.